Part A, we have square root of 7 sine x plus 2 cos x, and we need to write it in the auxiliary angle form of r sine x plus alpha. R is positive and alpha is acute. We need to state the exact value of R, and alpha must be correct to 2 decimal places. On the right side, we can expand sine of x plus alpha using the compound angle formula. So that becomes sine x cos alpha plus r cos x sine alpha. We can equate the coefficients of sine x. So we look at the coefficient of sine x. On the left, that is square root of 7. On the right, we have r cos alpha. So that r cos alpha equals square root 7. Let this be equation number 1. And equating the coefficients of cos x. On the left, the coefficient of cos x is 2. And on the right, the coefficient of cos x is r sine alpha. We have r sine alpha equals 2. And we say that this is equation number 2. To find the value of r, we take the sum of squares of equation number 1 and equation number 2, so that we have r squared cos square alpha plus r squared sine square alpha. That is the sum of squares of square root of 7 and 2. We can factor r squared so that we have cos square alpha plus sine square alpha equals 11. That from the Pythagorean, from the fundamental identities of trigonometry, that is 1. R squared is 11. Then we say that r is square root of 11. Since we are only looking at the positive value of r has to be positive anyway. To find the value of to find the value of alpha, we divide equation number 2 by equation number 1. So r sine alpha over r cos alpha. And that is 2 over square root of 7. We can cancel off r. That will give us tangent alpha equals 2 over square root of 7. Then alpha is given by arctangent of 2 over root 7. Make sure that your calculator is in degree mode. Since alpha is in degrees, that is 37.09 degrees to 2 decimal places. We can write square root of 7 sine x plus 2 cos x to be square root of 11 sine of x plus 37.09 degrees. Part B, we need to solve the equation square root of 7 sine 2 theta plus 2 cos 2 theta equals 1. And theta is in between 0 and 180 degrees. Compare this to what we have here. So if we replace 2 theta, if we replace x with 2 theta, then we can use the auxiliary angle form. So from here, we are going to write x as 2 theta. And this part, the left side, becomes square root of 11 sine of 2 theta plus 37.09 degrees. That is 1. in order to solve this, we divide throughout by square root of 11, so that sine 2 theta plus 37.09 degrees is 1 over square root of 11. We need to find the reference angle, so we find the inverse sine of 1 over square root of 11, and that is given by 17.5484 degrees. That is two decimal places, so the reference angle should be at least 2 decimal places. Look at this part here. This is positive, and sine is positive in quadrant 1 or quadrant 2. Then 2 theta, this angle here, 2 theta plus 37.09 degrees should be a quadrant 1 or a quadrant 2 angle. Quadrant 1 is just the reference angle, 17.5484 degrees, and quadrant 2 is 180 degrees minus 17.5484 degrees. Now let's look at this. We need to find theta. So the next step is to subtract throughout by 37.09 degrees. This first angle here is going to end up negative, but theta is in between 0 and 180 degrees. So this one is going to be gone. We cannot use this. What we could do is we could add 1 revolution to this so that we have an angle between 0 and 180 degrees. You do not want to lose one solution. You take 360 degrees and add to 17.5484 degrees. Find the coterminal angle. That will give us 17.5484 degrees. 180 minus that is 162.4516 degrees. And the coterminal angle to the first quadrant angle is 377.5484 degrees. Then we subtract throughout by 37.09 degrees. You do not want that. That will give us, the first one will give us negative 19.5416 degrees. And we have 125.3616 degrees, 340.4584 degrees. That is not going to work, it's negative. We want to find theta, so we need to divide throughout by 2. A negative angle divided by 2 is still negative. Let's just forget about this, ignore this. That 125.3616, but we divide by 2, we get 62.7 degrees and 170.2 degrees. All these are in between 0 degrees and 180 degrees. So we have 2 solutions.